Hi guys, this video is about using significant figures in calculations. The other day in class we talked about how to identify how many significant figures you have in a number. Today we're going to talk about how you use multiple numbers in calculations and determine how many digits you should report for your answer. First, we're going to talk about multiplying and dividing with significant figures. In order to do this, you need to count the number of significant figures in each number of your calculation. The number with the least number of significant figures is how many significant figures you can have in your answer. Why do we use the least? This is because you cannot report an answer that is more precise than your least precise measurement, therefore the one with the least significant figures. Now we're going to do some examples with multiplying and dividing with significant figures. So our first example, the first step before you multiply is you need to count how many significant figures are in each number in your problem. So according to the rules, this first number has 1, 2, 3, 4, including the 0, sig figs. Okay, and the 0 is included because there's a decimal. Then we look at the next number. Well, it has a bunch of leading zeros which do not count as significant, and it has two non-zero numbers, so that has two significant figures. Which one of these is least? That would be 2. So my answer can only have two significant figures. So now that I know that, I'm going to go ahead and do my calculation. So I'm going to say 2.450 times 0.0045. Okay, so my answer, as shown on the calculator, is 0.011025. I can only keep two of those digits. So when I'm rounding, I can only keep two significant digits. These don't count, remember, because they're leading zeros. So I can keep this one and this one. Then I look at the next digit to see if this one rounds up, and it does not. So I should report my answer as 0.011, and then I have meters times meters, which would be meters squared. So that's my answer for the first one. For the second problem, I'm going to do the same thing. The first number has 3 sig figs, and the second number also has 3 sig figs. Remember, that leading zero doesn't count. So my answer should also have 3 sig figs. So now I'm going to do the math. 3.00 divided by 0.500. And that gives me an answer of 6. Well, what happens if you've got an answer of 6, but you're supposed to have 3 significant figures? You add a decimal place and 2 zeros afterwards. Now you have 3 significant figures. So basically, your measurement needed to be that specific. Now I have grams divided by milliliters. Those do not cancel out, so it is grams over milliliters as my unit. For the third problem, I have 1, 2, 3 sig figs here, 1, 2, 3, 4 sig figs here, and only 2 sig figs here, so I should have 2 in my answer. Now I'm going to do the math. 4.50 times 3.456 times 5.0 equals 77.76. I need 2 significant figures. You always start counting from the left. I need this one and this one. This one causes this to round up to 8. So I should report this as 78. Now, I have centimeters times centimeters times centimeters, so that will be centimeters cubed for my units. So remember, when you're doing multiplication or division, you need to make sure that you look at the entire number and determine how many sig figs. The least sig figs is what you should have in your answer, and you're going to have to round to get there. Okay, now we're going to talk about addition and subtraction. The rules for addition and subtraction are a little different. When you're adding and subtracting using significant figures, you only count the number of significant figures to the right of the decimal place. The number with the least significant figures to the right of the decimal is how many you can have to the right of the decimal in your answer. Why are we only looking to the right of the decimal when we add or subtract? simply because those are the digits most likely to be affected from those operations. When you add and subtract, the ones that are going to be affected the most are the ones to the right of the decimal place. Let's do some examples. So for the first example, I see that I only have one digit. I only have one digit to the right of, here, let's try that again. One digit to the right of the decimal place here. When I look here, I don't see a decimal place, which means I have 0 sig figs to the right of the decimal place here, and I have 1 here. Well, 0 is smaller than 1, so I should have 0 sig figs to the right of the decimal here. So I'm going to complete my calculation. 24.5 minus 23. My answer is 1.5. However, I cannot have this to the right of the decimal, so that means I need to round it up to 2. And since I've got milliliters minus milliliters, it is still 2 milliliters. So that is the appropriate number of significant figures. Now let's look at number 2. I have 2 significant figures to the right here and only 1 here. So 2 sig figs to the right and 1 sig fig to the right. So I can only have 1 sig fig to the right in my answer. So 770.99 minus 245.5 equals 525.49. So I can only have 1 sig fig to the right. The next number over causes that to round up, so I should report this as 525.5. And I've got grams minus grams, so grams is also my unit. All right, last example. I have 2 sig figs to the right here, 1 sig fig to the right here, and 3 sig figs to the right here. So I only need 1 in my answer. So point whatever. So let's do the math. 3.90 plus 4.9 plus 2.546 equals. So I've got 11.346. I'm going to go ahead and write the 11. I can only have 1 sig fig past the decimal place. The 4 does not cause that to round up. So I'm going to keep it as a 3. And all of my units are meters, so it will stay meters. When I'm adding meters to meters, it's meters. If I multiply meters by meters, it's meters squared. I hope this helps. If you have questions, please let me know.